What do I do? I'm going away.
What are you looking for? You got a friend out there?
Earrings, big knee.
Wait.
Bro, listen to Sue.
Robbie, go ahead, open the door, man.
They're still sitting out.
Who?
She still hasn't came out. He's picking my bags.
Who? Put your bag back on your bag. On your bag. Like,
Yo. Oh, my kneecap.
I think he's slow back.
put it on your bag. What's the difference?
Yo, bro, wait. You're not ordering. On your back. No, leg back. What? Leg back.
Honey's not.
Yo.
Alright, y'all need to sit back down.
He says that. He said honey.
Y'all go ahead and sit back down.
Honey went in the back like a little.
Y'all go ahead and sit back down. We're gonna try again.
Honey went back.
Y'all go ahead and sit back down.
It's cool, honey. Bro, look at
Jay, go sit
Not winning.
How did you catch me? It was not seriously, bro.
You did not say butt.
Hey, sit down. Sit down.
Yeah, he's not.
Right?
Why is Brady sitting down? Go back up there.
Brandon.
Yeah, why is
That means. I need a single file line. I need. Why y'all so loud? It's time for y'all to leave. 1, 2. I'm gonna see y'all at the table tomorrow. Not all of you, but some of y'all.
Me?
It's gonna be a surprise.
No, genuinely how?
I said some of y'all.
Oh.
Y'all got me?
I was fighting until now.
What line up?
I swear on my.
What line up?
How does that have Sunday?
What line up? What line up?
Just say on bro, just say on bro. How did I get Sunday? I swear on Jordan Yo-Yo. How did I get Sunday? Let's check it out. I swear on
Jay's taunting me.
You gave me Sunday.
You don't got something.
What did I do?
Yeah, what was Logan doing?
Not here.
Why do I
You know what you get up.
What? No, I was telling him to be.
It's not a surprise that you're gonna
I
say.
was telling him to be.
Come on, y'all leave.
What? I thought it was. No.
Put everything else away.
Just go ahead. We go on. I'm gonna keep it a surprise for you. Surprise style. I'll be alright.
He's scared.
You smell good.
What's up, dude? You alright?
He said he would go to the
For what?
Wait, slow down.
Tore out for what? No.
Man, what?
Are they ready, Miss Watson? Alright, come on. Grab your notebooks and some colors.
Color? Y'all color on our pencils?
y'all might cover today
Y'all about to stop pushing me.
if we get to whatever we need to do.
Never mind. Did you change seats yet? Okay.
Go, sir.
No, ma'am. No, sir.
Grab your notebooks, grab some colors.
I need some colors. Not you walk I have balls. Are you recording something?
Yes, it's recording now.
When it's recording.
It's live. She's recording. She's recording is crazy.
Where's the color pencil? He's recording. Where's the so slow? Is that right?
Wait, is it actually?
Where's all the
Oh wait, it is.
Delaney, do you know where the colored pencils are?
No.
Where's our pencils?
No, it actually is.
Why are you recording? It's for the government. Yeah, and it's for the
So, I told you.
Mommy, it's for the state. It's for everyone that
They're gonna see. If you hear me by once, twice, everybody should be seated in their seats with their notebooks out, something to write with, and color pencils. Moving forward, can I have someone pass this chart out?
Me.
Okay.
You said I should have
If I can find it. Yeah. And
You break from mommy. Your throat sounds tired.
Madison is gonna pass out more sheets. So it's this one. So everybody should have a chart,
I'm sorry. I did not mean to pull much of mine.
and then everybody should have 2 extra sheets. So you should have 3 sheets in total. Your notebook, yes, but we're not writing stuff down in the notebook. No computers. So, like I said, we are moving on. Abdul, have a seat. Thank you.
Marty's coming. That's for the intern. Oh, this is the intern.
So, moving forward. So, moving forward, I need everybody to listen. I need everybody to pay attention.
I'm looking.
No, we're moving on to. So, everybody should have. Everybody should have this chart, and everybody should have both of these.
I don't.
They're still passing them around.
Thank you.
I should have 3.
What y'all do yesterday? Can you say? I only have one.
They're still passing 3.
That's always happy.
Alright, so I'm going to give y'all a warm-up. Our warm-up is going to be a quick little video on why our planet has layers. After that, we're going to continue with some notes. I'm going to show y'all and talk about what we're talking about. Alright? Yes, can you please sit down on this one? Thank you. So, I'm going to play the video about 4 minutes long. And then after that, we're going to get ready to talk about what we're talking about today, and that's our layers. Cool?
Yes, sir. It's okay to be
Hey, I'm just making a planet.
everybody
Well, this is how planets like Earth get their structure anyway, because of different layers of density. Even today, with all of our modern technology, we've only been able to drill about 1/3 of the way through Earth's crust. So, how do we really know if it's solid, liquid, hollow? Luckily, Earth has this tendency to violently shake and occasionally burp up some of its insides. And that's taught us a lot about our planet's guts without having to go down there. We're used to seeing density at work. That's the same reason that the atmosphere, the least dense part of our planet, is on the outside. And the crust, the second least dense part of the Earth, is beneath our feet. Because I'm less dense than the dirt, I don't sink into the ground. And even though there's about 1 ton of atmosphere above my head, it's not dense enough to send me floating. The main layers of the Earth are organized in the same way. Depending on whether they're divided up by how they squish around or what they're made of, geologists give different names to the different layers of the Earth. So that's how it is now. But to really understand why the Earth is organized the way it is, we need to go back to before our planet even existed. In the very young universe, hydrogen and helium were pretty much the only elements around. They condensed into stars, began the process of nuclear fusion, and eventually died, spitting heavier elements from carbon and oxygen to things like nickel and gold back out into the universe. One of those heavy elements, iron, is the most stable element produced outside of a supernova, and the early universe produced a lot of iron. That'll be important in a second. Fresh hydrogen and helium went on to form new stars like our sun, and the heavier elements collided to form the dust and debris that would become our solar system's planets and moons and asteroids and everything else. High temperatures in the early inner solar system meant that light volatile elements can only condense further out, which is why the 4 inner planets of our solar system are dense and rocky, while outer gas giants like Saturn could hypothetically float in a really big swimming pool. After proto-Earth grew larger, radioactivity, gravity, and violent boom booms melted that messy mixture of rocks and minerals, and this is where things started to get organized. Just like that tower of density, the heaviest materials like iron and nickel worked their way to the core. The lighter materials like aluminum and silicon stayed near the surface. The inner core experiences pressures more than 3 million times what we do on Earth's surface, which means that despite being as hot as the surface of the sun, the iron in our planet's inner sphere is likely solid and not liquid. The outer core is most likely liquid because it's hot, but not under as much pressure as the inner core. We know that's the case because of earthquakes appearing on the surface. As certain kinds of seismic waves travel through the Earth, the liquid outer core either refracts them or blocks them altogether. And that creates seismic shadows on the opposite side of the planet. If you want to use pressure to melt metal at home, just stack up 16 million pennies. The one on the bottom should liquefy in no time. Mercury is so close to the sun that its atmosphere has long since blown away. But luckily for you and me, our liquid metal outer core lets us have an atmosphere. Deep metallic convection currents create a magnetic field that shields Earth from the solar wind. Otherwise we'd be pounded with deadly radiation, our atmosphere would be blown away, and Earth really wouldn't be a very lifey place. Over time, Earth continues to cool, so more and more of its liquid outer core is turning solid, and we're shrinking little by little. Every earthquake that we feel is Earth taking one step closer to cooling off and becoming a real third rock from the sun. So there you have it. Like Carl Sagan said, we are star stuff who has taken its density into its own hands. It's density, right?
Density.
Stay curious. People have been looking at clouds since people have been people.
Yes,
Those billowing shapes might have been our first art, or the characters in our...
What? That's such an art
Alright. So this is what we're gonna do. I need about 4 people to give me a fact, or not even a fact. I want to know, because what we're focused on is really the layers. Can someone name a layer of the Earth? Kana. The mantle, good job. 1. Berkeley, can you give me a layer of the Earth? Inner core. 2 more. London.
Crust?
Crust? Alright, one more. Jamal. She took yours? That's alright, that's fine. Alright. Outer core. So, what we're gonna focus on today, right? I want y'all to figure out, I can ask questions that compare and contrast Earth's layers based on densities, temperature, thickness, and composition. So what I'm gonna do, right? I'm gonna draw it. I can't draw it, but I'm gonna draw it. Right? Maybe later. Right? I'm gonna draw it. And then I'll draw this, but I'm gonna draw it for y'all. But I need a marker. Can everybody see this?
Yeah.
Can everybody see that? Is
Yeah.
that too faint?
No.
Alright, so tomorrow, I'm gonna give y'all a foldable. Y'all can cut out like a little booklet. But right now, I'm gonna draw it for you. So, this is the Earth. Earth has 4 distinct layers. So we're gonna do red in one of them. Blue is 1, red is 1, orange is 1, and I need one more marker. Give me 1 second. Yeah, I'll have it. You want pink? If I find pink, then we can use pink.
You know you gotta pick a marker over there, right?
It's a highlighter. Alright, so got brown and I got purple. I'm gonna use purple. Right? So I have purple. I know that we have the crust, and the crust is broken up into 2, right? I have the mantle in red. The mantle is also broken up into parts, but it's 3. Right? So the mantle has 3 parts. The crust is 2. And then we have your outer core, which is in orange. Right? Outer core, and then your inner core, we got it in purple. Right? And we'll learn that there's a lot of fun different things about these 4 layers. Like the mantle, we're going to talk about the 3 parts of the mantle. Really, we're going to focus on 2 of them, right? And that the crust is broken up into 2 parts, being oceanic and continental. So what we're going to do though, right? We're going to look through these slides together. It's about 9 slides, not bad. And you don't have to write stuff down today, but tomorrow you got to write stuff down. But it'll be a little easy though. I'll make it easy. So, everybody has that chart out? Everybody has the chart out, right? This chart right here, with the black spaces. This is going in your notebook. You can fold it in half.
Can I cut around it?
You can cut around it too, but not right now. You can do that once we're finished with everything. So, everybody can see the board. So I'm gonna do it with y'all, right? So like I said, the crust is broken up into 2 parts, right? Crust is our thinnest layer, outermost layer on top of that. And the first part we're gonna talk about is the continental crust, right? So the continental crust is made mostly of granite. It's solid layer, thick but not very dense. Goes 21 to 43 miles thick in some places, and it's the coolest layer. So I'm looking at this chart right here on the board, right? Everybody can see this chart, right? Let me know if you need me to go closer. My handwriting's bad too, but we'll figure it out. All right. So for the composition, I'm gonna put solid. So everybody's gonna put solid in this first little part right here. Everybody sees that? Right? Solid. Right here at the top. Alright? After I put solid, I'm going to put made up of what? So it's made up of mostly granite. Right?
Granite. And that is
Yes. But mind you, it's also up here too. What you're looking for. It's beside.
Oh.
Granite, right? And then we're gonna see, is it the hottest or the coolest? Obviously, we live on the continental crust. Is it hot?
Cool.
It's the coolest, right? Because we're gonna see moving forward that the lower you go, the deeper you go, the more denser, the hotter, and the more pressure you have, right? It's the coolest. Is it thick? Yes, but is it the thickest? No. So we're gonna put thinnest, because it's the crust. Yes, sir.
So pressure can make things hotter?
Hmm?
Can pressure make things hotter?
Not in some cases, no.
This is thinness?
And yeah,
Yeah.
so in the case of the ocean, you know, it's more pressure, right? But it's colder the deeper you go, right?
Yeah. Okay.
But with the earth, it gets hotter. Yes.
If you know, like the sun is really, really hot, if somebody were to if somebody threw somebody on it, would they instantly burn?
That's not really a question we're supposed to talk about now, or at all. But you know, I'll let you do some research on your own. And yeah, that's not. Moving forward. So, we also have the density, and you're gonna put the least dense, right? It's our thinnest layer. It's not really dense. If it was dense, we feel it, right? But, and then I'll pass around this, right? Kendall, do you wanna give one half to one side of the classroom? And then you give this half to another. It's kind of the same. So, everybody will get to see that while it goes around. Does everybody have this first line filled out? Thumbs up if it's filled out. Thumbs down if you're missing a part of that first row. What are we missing now, Blue? Density, least dense. So you're gonna put L-E-A-S-T,
I just put N.
and then you're gonna put D-E-N-S-E.
D-E-N-S-E.
D-E-N-S-E. So, we're good? Alright, I need everybody's attention. We're gonna move on. Boom. So, we have oceanic crust, right? And for oceanic crust, we're gonna put made mostly of basalt, so made up of what? B-A-S-A-L-T, basalt. But it's also a solid too, right? I'm not talking about the water, I'm talking about the bottom of the ocean floor, right?
So, sand is solid, right?
Basalt, B-A-S-A-L-T. So, you're gonna also put coolers, because we're still talking about the crust.
Connor asked if sand was solid. Wait, I didn't know, because sand can be a liquid, you know that, right?
Hey, we're not doing that. Moving forward.
Does that say coolest?
Yes, ma'am, says coolest. And it's also still the thinnest, right? We're still talking about crust, yeah.
There's like, the sand, with the sand at the bottom of the ocean, is that solid or liquid?
It's a solid.
Sand can be a solid, I mean, a liquid.
Okay. We're talking about the floor, like the ocean.
I know.
Okay. Moving forward, we're gonna also put least dense, because we're still talking about the crust. But which I would like y'all to do is draw an arrow going from here to right here, and you're gonna put more dense.
But what?
More dense, because
They haven't seen it?
the
Wait,
oceanic
how do you get to
crust.
see it?
Shh. Thank you. The oceanic crust is more dense than the continental crust.
Oh.
That's why I want y'all to put that. What's wrong? Okay. So, when you're thinking about the oceanic crust made mostly of salt, thin but dense, 3 to 6 miles thick, cool layer, because it's dense, it will always subduct or go underneath the continental crust when they collide. And we'll talk about that moving forward. We'll talk about that more probably next week. Yeah. And thumbs up once you have it written down. And then once you're finished with that, I need a scale from 1 to 5. 1 being this is confusing, 5 meaning I understand it completely, and if I were to see a question on this, I could handle it. 3 is in the middle. Like you're okay with it. 4, you're almost there. 2 is you're confused about. and one is I completely don't understand.
Okay.
All right, can I move on?
Yeah.
All right, so moving on. Now we're touching into the mantle, right? So the mantle is broken up into three parts: lithosphere, ascetosphere, and mesosphere, right? And we're gonna start off with the lithosphere. So this is more so the upper part of the mantle, and I have a poster to show y'all where that at.
A potion.
Yeah,
A poster.
a poster.
Oh, she's so funny.
So, but we'll talk about it later. Thank you. Let's focus, please. So I'll put it's a solid, right?
Yeah.
Still solid, and it's made of mostly rock, right? You can put right here, it's the thinnest part of the mantle. And that's right here on the slide. So the fun part about that,
You don't have to do your.
yes you do.
Then why didn't?
So with this one, with the lithosphere, your crust is attached to that, right? So it's attached like Velcro, right? So right connected, and I'm gonna show you right here. You have your crust at the top, your mantle is this middle layer, and then your ascetosphere is the layer underneath that, right? And I'll show you if this makes a little bit more sense. Right here, I'm gonna go up. Yes, London.
Does your stuff have to do with everything we say?
Soil? No. We're not gonna talk about soil right now. So everybody sees the green right here? Yeah, so this is your continental crust, right? This dark blue is your oceanic crust right here, right? We all see it?
Yes.
Your lithosphere is the brown. See how it's connected? And then we float right on top of the ascetosphere. So the ascetosphere is more like putty, like a slime. It's like slime. So it's not complete solid, but it's like it moves. It's not. Not really like lava. Because lava is like molten rock. Like liquid. It's confusing, right? Not clay. More so like slime. Does that make sense? You know how slime is not a solid, but it's also not a liquid?
Yeah.
It's kind of
It can be
like
dense.
So it's kind of like that, if that makes sense. So we float on it, and it kind of, we're going to talk about
The
it.
second one is shoes. The third says.
Are we done? Thumbs up?
Yes.
We got it written down?
Yes. Yes.
Who still needs to write this down? So we shouldn't be talking, right?
I get.
I got you. So, solid rock, you're also going to put thinnest part of the mantle, right? And that's it for that. Yeah, there's going to be more stuff. Can I move on?
Yes.
Okay, thank you. Boom. So, we got the ascetosphere. Middle portion of the mantle is made of molten rock, thick, a really dense magma that moves like slime. Really dense, right? No, it's in the earth, so it's magma. No, if it was outside, it's lava, but it's magma, right? So, what you're gonna put right here, you're gonna put a thick, dense putty, or you can put magma. Yeah, putty is spelled P-U-D-D-Y.
What?
Putty.
Putty?
Putty.
Putty. Putty, not booty.
I said P-U.
If you can hear me, clap once. So we're done with this side of the conversation. Thank you. Right? You can put molten rock for what it's made of. So melted rock, right? It's magma. No. You said you can't see it? I got you.
What that say? Oh.
So a thick. Let me move it back. So it's going kind of hard. Right. But a thick molten rock, well, a thick dense putty for the composition, you're gonna put made up of molten rock. Can y'all see it?
No.
No.
Yeah, right here.
Alright.
No.
And then you can put thickness. Right? Because it's the mantle. The mantle is the thickest part of the Earth's layers. Right?
So the thickest part of the mantle? Is like-
No, not the thickest part of the mantle. Just put thickness. You can just put thickness. But you can also say it's the upper part of the mantle too, but it's in between lithosphere and mesosphere. Thumbs up once you have that ready.
What's food made up?
As long as it helps you remember. Abdul, where you confused me?
Made up of what?
Molten rock. This one. You just need to remember where they are and what they're doing. I promise you, it's gonna be easy. This new line was kind of wow. It's gonna be easy. I'm gonna make it a little fun. We got a lab coming up.
Wait, is that what they're doing? What is the put?
No, they were doing a soil, but we're gonna do a density lab. So I'm gonna have the syrup and we gonna do your parents are gonna bring
Oh, we can eat it afterwards?
So, moving forward, relax. I know y'all like food.
Okay, that's so
That's not-
it's like the best thing.
So if I give candy out right now, you're not gonna ask for that?
I don't know about that. You can put me in
I thought you didn't like
I know you like that's
Then why do you think it's
Oh, you know.
food. If you can hear me clap once. Alright, let's focus, Let's focus. Alright, so we're at the last part of the mantle and then we're finished with this. After the last two. So we got 3 left. So, yes, no? Yes, you can. Alright. So, the mesosphere is the bottom of the mantle. You're going to put it's solid, and then it's made up of rock. Right? And then you're going to also put thickness. Because we're still talking about the mantle, right? And that's pretty much it, right?
Is that thick?
It's the hottest part of the mantle, but it's not the hardest part of the Earth's layers. Yes, ma'am.
So not to get confused, can I put right here like on the mantle?
Yeah, you could do this here in the